So today is day 5 and day 6. We started preparing a solid principle system design. So in that today we are going to see solid principles as day 1. So this solid state principles has 5 principles which has uh, which have a single responsibility principle, open closed principle, and Lisco substitution principle, and interface segregation principle. And fifth one is dependency inversion principle. Let's go through the principles one by one. Single responsibility principle. So, what the single responsibility principle says. For example, I have one class uh, file. Okay, and this file has two methods. One is open file and print methods. As you can see, this file and the print are different, right? So file can open, we can open the file and modify the file, copy the file. These are file extensions. But print is something related to the printer, right? So here this file is doing opening the file and printing the file. So this is not correct, right? So instead, what we can do, we need to create one class file here, open file, and we need to create another class printer and print method. Now you can ask how we can print the file. We need to create one common method, uh, file handling something or file processor, where we can have in import file object and printer object. Now we can say open file, then print it, object 2 dot print. So what the single responsibility table says, so the class should have only one responsibility. It should not have both the features. Well, for example, there is another example, report generator. Okay, it consists in same file, and we have some report. Okay, uh, class report, and it says generate report and save report or save file. Okay, here also this is two different reasons, right? One is report, generate the report, and save report. Instead, what you can say, create one report generator class and create one report saver class. So now both are independent, right? So this is what's the second first principle says, single responsibility principle. And now the second principle, open or closed principle. What this open or closed principle says is class or interface should a class should be open for extension, but we need to close it for modification. For example, I have one payment. Okay, there is one payment processor. Okay, in that we will pass type. Okay, if type dot equals credit card, then do something, or what you can say, pay. Okay, pay credit card. Now if type dot equals debit card, then pay debit card method. Okay. If you see this, now I want to include UPI. Then again, I need to modify this method, right? Modify this payment process. Okay. So instead, what I can do, I can create some generic method which can extend. So now, if I want to extend Google Pay, I need to modify this payment processor, right? So instead, what I can do, I can create an interface, class payment, sorry, interface payment, and this class has the pay method. Okay, and now what I can do, I can create one credit card payment class, credit card payment implements payment pay credit card paid. Similarly, we have a debit card payment and UPI payment, which includes implements payment. Okay. Now the payment processor you can modify the payment processor class payment processor process method. It can accept the interface and payment dot pay method. Now it is very much simplified. Right? Earlier we have a in the payment process we have a list of payment types and each types we need to implement manually. Type dot equals credit card payment, debit card payment. Now we have created this payment interface and we have created a classes. Now if you want to create a new payment, we can create a class and implements the payment interface. Correct. So in that payment process, the process method, we are processing that payment and the payment.pay method implements. So this is called the open closed principle. Now we can see the next principle of Liskov substitution principle. In the Liskov substitution principle, uh, simply we can state that if class promises something, if superclasses promise something, then the subclass has to be in the subclass it has to be fulfilled, or it, it is possible. For example, class bird, and this has the method of fly, s out flying. Now there is another class, uh, class parrot extends bird, and now this can also have fly method. Parrot is flying. Now we have a class ostrich extends extends bird. Now we have a fly method, but the ostrich can't fly, right? But what the superclass promised, it can fly. So this is wrong, right? So what the Risco substitution principle says, so the every subclass can be uh, fulfill the superclass, or we can say every superclass. subclass should be replaceable by its superclass without breaking the system. So this ostrich can't play. We can do one thing. We can throw unsupported exception, but this is wrong. This is not a standard approach. What we can do, this fly has to be a separate interface, class build, and we have an interface flyable. Okay, and now what parrot can do? Class parrot extends build, implements flyable, and this flyable has a fly method. Now parrot can use the fly method. Now ostrich class ostrich extends bird. Now ostrich can't fly. It can implement its own method. So Lisco principle says subclass should be replaceable by its superclass. So when I call the ostrich dot fly method, it has to be flied, or that our implementation is wrong. We should create a interface to manage that. Or we can say there is another approach. Instead of this using interface, we can do refactor. We can create one another class. Instead of interclass, we can create a flying bird something. Then the flying bird extends bird. Okay, class bird and class flying bird extends bird. Now it has the fly method. Okay, now this class flying bird can extend. Parrot can extend this flying bird, and ostrich can extend bird, not flying bird. Okay, so this is also we can do. Uh, there are two options: interface or this new class without breaking the system. And now next we see the fourth principle, interface segregation principle. So in the interface segregation principle, same like a single responsibility principle. We should not have unrelated methods in the in one single interface. For example, interface uh, action, move function, eat function. Now we have class human, implements action. Now we can implement move function, eat function. Okay, but we have another class, robot, implements action. Now robot can move, but eat function not possible, right? So instead, what we can do, we need to split the actions, interface action, or what we can simply do. Similarly, we can do like interface action, then movable interface movable action, and extends action. Okay, but we can do another approach, interface movable action and interface eat action. So this is also possible. So now what we can do create another method. Sorry, we'll see the next final principle, dependency inversion principle. So what this dependency inversion principle says, the dependency inversion principle, let's say class B directly uses class A. This is very, very wrong. Wrong. What we need to do, this class A, right? This class A, for example, let me show one example first. First, let's say class keyboard or light, okay. And I can have a keyboard can have a type method, and light can have a uh, turn on method. Something wrong with my pen turn on method. Okay. Now I have a class B computer. Now this computer can extend keyboard. Okay. Uh, Now type method. Okay. But if you see this key now this computer can't use other keyboards like Bluetooth keyboard. Correct. So what we can do, this class keyboard, right? This class keyboard should not have this type method. Class keyboard should have implement some interface like type method. Okay. Now in the type method, we need to pass the type correct. From the type, it can print. So what we can do? We can create one uh, keyboard and a Bluetooth keyboard class which implements type interface, typing interface, and in that we have a type method. Okay, and this keyboard method, right? Keyboard method passes this type. This is a general keyboard. Okay, and the keyboard method, if we pass that type inter or we can say the computer, I can have type. What is happening? Type method, and this type is an interface and type. Okay, typing in the computer, I can pass the type interface. Which typing? And this can be instead of this class keyboard method, I have created a input device, and this input device can have a class keyboard and class Bluetooth keyboard. Okay, actually we can use the same class keyboard, and instead I can create another keyboard class Bluetooth keyboard which implements this type. Okay, and the same we can pass the typing method, and using that typing method we can print. In the typing interface I can pass uh, uh, Bluetooth keyboard or a regular keyboard, manual keyboard, mechanical keyboard. So this is how we can print. Actually, hope this logic explains well because I can't use pen.